welcome back everyone. This one is year 12 technical drawing course plotting. Today we're going to look at exercise 2. Right, if you refer to your workbook for exercise 2, you can see a screenshot there. So in this exercise you're going to learn some new concepts. So before we start doing this question, we're going to look at those concepts in detail, then we'll solve the questions. Right, if you look at the question, it says a ship Fisher 1 leaves jetty on a bearing of 50 degrees until abeam to beacon 1. She then changes bearing and sails on a course of 80 degrees at a speed of 12 knots for 45 minutes. She alters course again to clear the wreck to starboard by 1.5 nautical miles until light 1 and light 2 are in transit. She then heads on a bearing of 190 degrees for 4.5 nautical miles. The captain decides to take a 3 bearing fix. Beacon 1 bears 300 degrees, tower 2 bears 266 degrees and light 3 bears 054 degrees. You are required to plot the ship's course and also find the distance of the ship from the wreck to the 3 bearing fix. So if you look at the things that we are going to look here, right, so the new terms that we are going to look at in this question, the first one is abeam, the second one is the speed of the boat, that is 12 knots, and the third one is transit bearing, and the third one is and the fourth one is 3 bearing fix, right? So these are the 4 new things we're going to look at in this question. The first one, let's look at what is abeam. A beam bearing is a right angle or 90 degrees to the ship, as you can see in the picture. The ship was going in the direction that is indicated there, then a beam bearing is taken from Suva point. Right, the ship changes direction when Suva point is abeam. So this means from Suva point a line is taken which is 90 degrees to the direction of the ship. The next one we're going to look at is transit. Transit, it simply means when 2 beacons, landmarks or light kept in a line. This is frequently used by ships while entering or leaving the harbor. Lights are used at night and landmarks during daytime. So if you look at the diagram there, the ship changes course when Levuka airstrip and Gao airstrip are in transit. So in transit means you are going to join the 2 landmarks in a straight line. It's like you are given 2 points, you join the 2 points in a straight line. That's what transit means. Right, so our next concept that we're going to look at today, it's a 3 bearing fix. Right, so the 3 bearing fix often do not cross exactly at a point but forms a small triangle. Sometimes they will cross exactly at a point, sometimes they will form a triangle. So when they form a triangle, this is called cocked head. Right, so this is called a cocked head. The position of the ship is taken in the center of the triangle. So the triangle that we are going to form, which is called the cocked head, the position of the ship is in the center of that triangle. Right, so if it meets, if all the 3 bearings meet at a point, then no worries. But if it forms a triangle, this means you are going to take the center of the triangle as the position of the ship. Right, so you can see in the diagram there, 3 bearings were taken. One from Savu Savu, Namatalata and Tavanga to locate the ship. And in this case they are forming a triangle, so the small dot inside the triangle, that is the center or the position of the ship. We're going to draw the first leg. So it says the ship Fisher 1 leaves jetty on a bearing of 50 degrees until abeam to beacon 1. Right, so what you will do first, we will transfer the true north, which is here on the jetty. This time see we don't have a small cross here, so we will start directly from the jetty. Right, so once we have transferred our two knots there, we are going to measure an angle of 50 degrees and we are going to draw a line. That's 10, 20, 30, 50 is here. and then I'm going to join this point to the starting of the jetty. Right, so I have joined this point to the starting of the jetty. Now it says until abeam to beacon 1. Abeam means from beacon 1 there should be a line that should be going at 90 degrees, right? And to draw that line, this is how we draw the abeam. Right, so you can to take your compass, draw one arc on the line, then you can to actually bisect that arc. So you'll get the intersection, join that intersection back to beacon 1. And that is your abeam. So the point where it crosses the line, that is where your ship, the first leg of the ship finishes. So you can make that much dark, label it as leg 1 and a bearing of 050 degrees. Right, the next part of the question says C then changes course C then changes bearing and sails on a course of 80 degrees at a speed of 12 knots for 45 minutes. C alters course again to clear the wreck to starboard by 1.5 nautical miles until 1 and 2 are in transit, right? So first we have to look at the course of 80 degrees at a speed of 12 knots for 45 minutes. Right, so you're going to transfer your north at the end of the leg 1 where your beam bearing intersected, and then you're going to measure an angle of 80 degrees. You can draw the arrow there, label N, and measure an angle of 80 degrees. Right, to find the distance there, it says it travels at a speed of 12 knots for 45 minutes. You can see I have already done the calculation there. Distance is equal to speed times time. Right, that's the formula for distance. If you look at speed is equal to distance divided by time. So when you rearrange for D, you get speed times times. So your speed is 12 nautical miles per hour or 12 knots, and the time is 45 minutes, so we have to convert that to hour. So 45 divided by 60. So 12 times 45 divided by 60, that is in the bracket, you are going to get 9 nautical miles. So from the end of leg 1, you are going to measure 9 nautical miles on the leg 2, and that is going to give you the end of leg 2. Right, these distances are taken from your scale. You can draw the arrow there, label it as leg 2. The bearing is 80 degrees, and also you can write down 9 nautical miles. The next part of the question, see alters course again to clear the wreck to starboard by 1.5 nautical miles until light 1 and light 2 are in transit, right? So you're going to take 1.5 nautical miles from your scale, Draw a circle. Join the end of leg 2 to the center. Bisect that line. And draw a semicircle. It says you are going to clear the wreck to starboard, right? So that is the reason why my ship is going in that direction. Right, let me make a sketch of a ship there. Starboard is your right hand side of the ship and the left hand side is port side. So when it says clear starboard, this means your right hand side should touch the circle. And if it says clear port side, then your left hand should touch the circle. Right, so until light 1 and 2 are in transit, so transit means you're going to join with a straight line, and that is the end of leg 3. Right, you can just write down, draw the arrow there and write down leg 3. Right, so once you have finished with that, she says, she then heads on a bearing of 190 degrees for 4.5 nautical miles. So you'll transfer your north there. We are going to take an angle of 190 degrees. And on that line, you're going to measure 45 or 4.5 nautical miles. Right, that's 190 degrees. You'll join it there, draw the line and measure 4.5 nautical miles. So that's how you measure 4.5 nautical miles from the scale, right? That is going to be your leg 4. Can make it dark, draw the arrow, label leg 4, write down 190 degrees and 4.5 nautical miles. Right, after that it says the captain decides to take a 3 bearing fix. Beacon 1 bears 300 degrees, tower 2 bears 266 degrees and light 3 bears 54 degrees. So at beacon 1, tower 2 and light 3 you are going to draw true norths there. At beacon 1, tower 2 and light 3. Right, so you can see I've already going to take from here true north, transfer it on beacon 1, tower 2 and light 3, then you're going to measure the angles. So beacon 1 bears 300 degrees. That's 300 degrees for beacon 1. Tower 2 is going to bear 266 degrees. And the last one, light 3, is going to bear 54 degrees. Now I'm going to join the lines. So beacon was 300 degrees, but when I join the line, I'm going to extend it in the opposite direction. Right, so 300 degrees I have extended it down. Same thing I'm going to do for tower 2 and light 3. So that is tower 2 and the last one is light 3. Right, so in this case I'm getting one single point, not a triangle, so you can just label that as your position of the ship. Right, now you might be thinking that the ship was at leg 4, how come the ship is there? Now this is called drifting. So from the end of leg 4 you are going to join it to the point that you have located using hidden line and label it as drift. Right, when you anchor the ship at some place, or when you stop the ship there due to the wind effects and other things, your ship is not going to remain there, it's going to drift. So these bearing fixes are taken to find the exact location of the ship. What is the distance of the ship from the wreck to the 3 bearing fix? So what you're going to do there, use your scale, that maximum distance I can take from the 6, I mark it there, then that much is left, I'll take that much. Right, so what I'm going to get there is 7 nautical miles. Right, don't try to follow what I've written there, actual answer should be 7.2 nautical miles. It's getting maximum of 6, then plus 1.2 is going to give you 7.2, not 6.2. Right, so that's the end of this question.